Hi guys, welcome to day 5 of placement series, and in this video we are going to study about time complexity and the big O notation. So what is time complexity? Time complexity is a measure of how efficient an algorithm is, and also it says about the runtime, or it gives a relation between the time an algorithm takes with respect to an input. So if the input increases, how long the program will take to run. That's what time complexity will give. And we have this rule of thumb in platforms like LeetCode that the number of operations for a specific program shouldn't exceed 10 power 8. And if the number of operations exceed this number, then we get an error like time limit exceeded. So for example, we have an input for input say 10 power 5, like n is equal to 10 power 5. And if the time complexity or the big O notation is big of n, that means the number of operations which the program will take at max is 10 power 5. So this is less than 10 power 8, the program will execute. And if the time complexity is, let us say, big of log n, that means the maximum number of operations is log of the number of input size. Here if we do this log of 10 power 5, we get 5, which is also okay, which is less than 10 power 8, and the program will run. But if we have, suppose, n power n or 2 power n, then we get 2 power 10, which is much greater than 10 power 8. Or if you have doubt, let us say n power n. N power n is also 10 power 10, which is greater than 10 power 8. So it will give an error, that is time limit exceeded. So we have different types of time complexities, like here we have a graph. Let's draw this graph. On the x-axis we have the input size or the n, and on the y-axis we have the number of operations. The number of operations is indirectly the time taken. So the first one is big O of n, big O of 1, that is constant time. What does this mean? Like for any small input or for any large input, the program will take a constant time. Like if it takes 1 second to execute for like 10 number of inputs, then it will take 1 second for 1 billion inputs. And the next one we have big O of log n. And the third one is big O of n, that is linear time. As the number of size increases, the number of operations will increase linearly. And then we have big O of n log n and big O of n square 2 power n, and at the end big O of n factorial. So this is the best time complexity and this is the worst time complexity. Now if we take this big of 1, which says that it is a constant time and it does not depend on the input because there is no n in here. However large the input is, same time is taken. Similarly, big O of n, linear relation, and big O of n square is quadratic. If we have n is equal to 4, then number of operations will be 16. So how do you find out uh, what type of time complexity a program is taking? Suppose we have a program, for example, we have a function which takes an input of int n, suppose, and it just print hello world, or just say hello. So if if n is 1 or n is 100, it will just print hello once. So if it takes 1 millisecond, then for all number of n's it will take 1 millisecond. So this is constant time, so this is big of 1. It does not depend on the input. And similarly, if we have a for loop, for example, we have a function that takes n, and we have a for loop which goes from int I is equal to 0, I less than n, I plus plus, and it prints hello. So here, if n is 1, then hello is printed one time, but if n is 1000, then 1000 times hello is printed. So this is linearly dependent on the input size. So this is big O of n. And the third one, if we have two for loops, for int I is equal to 0, I less than n, I plus plus, and inside this for loop we have uh, one more for loop which goes from j is equal to 0 to n, and we have print statement. So for each I equal to 0 or I equal to 1, we have j going from 0 to n. So this takes big O of n square time complexity. And suppose we have multiple operations in the same program. Suppose we have a for loop, we have some other statement, and if this for loop takes n square, this one takes n, and this takes constant time complexity, we just add them. So the time complexity will be big of n square plus n plus 1, and at the end, the n with the highest degree will be the final time complexity. So this will be big of n square. So thanks for watching.